Hello everyone, please subscribe to get the latest updates. Let us solve problem number 5. This is worth 19 marks. Daisy invested 37,000 Australian dollars in a fixed deposit account with an annual interest rate of 6.4% compounded quarterly. After M months, the money in the fixed deposit account has appreciated to more than 50,000 AUD. Calculate the value of Daisy's investment after 2 years. So we can use the formula for compound interest. So our A, we're looking for the future value or the amount, which is equal to, use the formula for compound interest. I will just write a substitution here. So the principal is 37,000 multiplied by 1 plus 6.4 over 100 because it's 6.4% times quarters, which is times 4 raised to nt number of years and the quarters. So that's 4 times 2. Okay, this gives you 42,010 Australian dollars. You can also use your financial solver where n equals 2, PV equals negative 37, which is the investment. Your I is equal to 6.4. Period per year is 1. C, compounding per year is 4. Now, if you chose this to be in, let's say, 4 quarters, and then you're paying 4 times a year, then your N shall be 8 times for 2 years. So negative 37,000, 6.4. You will still be getting the same FV when rounded off to 3 significant digits is equal to 42,010 Australian dollars. Find the minimum value of n where m is a natural number, element of natural number. So we're looking for m, which is the number of months. Okay, it says that, where shall we get our m? We must consider this statement. After m months, the amount of money in the fixed deposit account has appreciated to more than 50,000. So for letter B, so we have 37,000 times 1 plus 6.4, 100 times 4 raised to n. It's more than 50,000. So what you can use here is the numerical solve. This gives you the value of n, which is equal to 4.792231. But this is in terms of year, because our formula, if you're going to look at your formula booklet, the n there refers to n in terms of years, or I think they use t in terms of years. So to make this in months, you multiply that by 12. So that will give you 56.9 something. But then it says m is a natural number. So our M is equal to 57 months. Okay, months. I'm having trouble with my stylus. Okay, now let's solve letter C. Let me move this a little. For letter C, Daisy is saving to purchase a new apartment. The price of the apartment is 200,000 AUD, and he makes an initial payment of 25% and takes out a loan to pay the rest. Write the amount of the loan. So the loan, you don't really need to show the solution, but I'm going to write here, or just after the answer. Anyway, that's only 1 point. So the loaned amount is 75.75 times 200,000 AUD. So the answer here is 100, just 3/4, right? 150,000 AUD. The loan is for 10 years and compounded monthly with equal monthly payments. This is your PMT, 1,700, made by Daisy at the end of each month. For his loan, find the amount of interest paid by Daisy. So let's just use the TVM here. Let me move this so we can have space. Okay, I need the data. So for letter D, our find the amount find the amount of interest paid by Daisy. The loan is only 150,000, but if she is paying 1,700 AUD in 10 years, which is 120 months, this is the amount paid, okay, total paid, but she only have a loan of 150,000. So how much did she pay on top of 150,000? So 1,700 times 120 minus 150,000 equals 54,000 AUD. So can you imagine that? The loan is only 150,000, but for 10 years, it accumulated an interest of 54,000 AUD. Okay, so letter E, after 5 years of paying off his loan, Daisy decides to pay the remainder in one final payment. You must consider that using in mortgage and annuity, the interest is bigger in the beginning. It is slightly decreasing until you have paid off the loan. Okay, so after 5 years, so Daisy paid for 5 years, and then after paying for 5 years, she did not continue up to the 10th year. She already paid the remainder in one final payment. Let us find the final payment after 5 years. So N is in 5 years. This is 60 payments made. What are we looking for? Oh, we still have to solve T number 2, sorry. So this one is T1. Okay, for D2, the annual interest rate of the loan. So N is 120, and then our I is missing, and then our PV, present value, is negative 150,000. This is actually the loan. Our PMT is 1,700. Yet you shall write every information needed. The future value shall be 0. So this is the time we have paid out the loan. Okay, let me move a little. We don't have space here. And then, wait, payment per year, 12, compounding, monthly. Okay, so you can see here, you make 12 payments in 1 year, and for 10 years, you will be having 12 payments. So this is 12 months. You're paying for 12 months. So you will be paying the whole thing for 120 months. Now this will give you an interest of 6.457, etc. So the interest rate is 6.46%. Okay, let's solve letter D. After 5 years of paying the loan, Daisy decides to pay the remainder in one final payment. So maybe we can have our E here. I'll just put a space here. For letter E, amount of Daisy's final payment. So what remains? What will be the future value after paying for 5 years? So, and 5 years is 60 months of payment. The interest, we just copy this, 6.457, just the original. PV is the same, negative 150,000. And PMT, you're paying 1,700. Your future value, this is what amount to be paid after paying for 5 years. So it's not 0 because we're not consuming the whole 10 years. And then we're having the same thing. We're making 12 payments in a year because it's compounding monthly. Okay. So this will give you the future value, which is equal to 86,973 AUD. Okay, rounded off to the nearest dollar, Australian dollar. Now we ask how much money does they was able to be saved by making one final payment after 5 years. Okay, so how do we do that? For supposed to be for 10 years, Daisy could have paid 1,700, which is the monthly payment, for 120 months. This is if she paid for 10 years, right? Or 10 years. But she only paid 60 times 1,700. So this is what she paid for 5 years. Okay. And then she paid the remaining after paying for 5 years. There's a remainder of 86,973 4,973. So this is the actual payment made by Daisy in 5 years. So paying for 5 years, 1,700 a month, plus whatever remains is being paid for. Okay, and then you subtract it from what would have been paid if she paid this for 10 years. So what we have here is 204,000 minus the sum, or the number, or the answer for this, which is 188,973. This gives us 15,027 AUD. Okay, so that would be all for number 5. Stand by for number 6.